Hello, I'm Shweta Shri. Our project is a memory card game implemented using ADTs with 8 focused tasks. My role was planning sprints, assigning modules, and tracking integration. Today, we will show how each task maps to code. The 2D matrix storage, the pair matching logic, searching for the special bulb, probability simulation, AI memory, difficulty scaling, scoring, and finally the integrated game loop. We used agile stand-ups, version control, and a final integration sprint to combine all modules into one application.
I am Harshita Ashni and I implemented matrix representation. We use character matrix grid to store symbols and in matrix reveal to mark visible cards. The display grid function prints for hidden and the actual symbol for revealed cells. Input validation ensure users give row column values. For different difficulty levels, we only use the upper part of the matrix grid defined at runtime. This module is simple but crucial. It's the ADT backbone the rest of the code relies on.
Hi, I am Thermal Santosh. I implement the pair magic logic. After two valid the flips, the programs compare the grid R1 C1 and the grid R2 C2. If the match are not a special tokens, the card stay revealed and we add the tens plus score. If they don't match, we flip the back and reduce the 5 points. This module also incremented counters for the wrong attempt and signally when all pairs are matched by checking the revealed state so the game can finish correctly.
I'm Darshni and I will search for the light bulb. The bulb is represented by at and randomly placed during shuffle. When a player flips a bulb, they immediately get 20 points. We also track the bulb's coordinate to provide a hint after 3 wrong attempts. The search behavior appears naturally in gameplay. Linear scanning by the user or strategic flip guided by the AI memory. This module also triggers the optional probability simulation when the bulb is found.
I'm Priyadarshini and I implemented simulate probability function. It computes the theoretical probability k by n of finding the bulb in the first k tries and runs trials to return a simulated probability. We use RAND function to simulate random selections over many trials and compare practical results with theory. This function is called when a player opts to evaluate odds after discovering the bulb, and we included printed summaries for both theoretical and simulated values.
Hi, I am Akshay, and I built the AI memory part of the game. The AI uses something called an AI memory array, which is like a grid that remembers the symbols and the cards that were flipped earlier. Each time a player flips a card, the AI saves both the position and the symbol. This way, it keeps track of what it has already seen instead of starting fresh every time.
Hi, I'm Dinesh Kumaran. When the AI plays or gives hints, it checks its memory to see if it already knows where matching symbols are. If it finds a match, it can suggest those cards or pick them directly instead of guessing. This helps the AI make smarter moves and reduces wasted turns. It shows how remembering past actions can make the game faster and more efficient.
I am Shafia and I implemented difficulty scaling. At startup, the player chooses beginner 2 cross 2 or medium 4 cross 3 or hard 6 cross 6. The program sets rows and columns accordingly and prepares the appropriate number of symbol pairs plus 2 special tokens at and x. Our shuffle card function handles any size by shuffling a symbol array, then filling grid row wise. This ensures our same code base supports all three gameplay sizes.
Hello, I am Komalata and I built the scoring rules. The score variable updates like this: plus 10 for correct letter pair, plus 20 for finding the bulb, and minus 5 for mismatches or finding an X. After each turn, we display the current score and increment a wrong counter for non matching attempts. The wrong counter triggers a hint mechanism after 3 mistakes. The scoring logic is simple but important for gameplay feedback and final ranking.
I'm Jayapriya, responsible for integration, QA, and demo packaging. I combine all modules into the main loop, initialization, shuffle, game loop, end check via all pairs matched. I wrote until check for shuffle length, input validation, and simulated playthrough to verify scoring and probability outputs. For the demo, I prepared sample run that show a typical game, bulb discovery, probability output, and final score. We also documented contribution and test evidence for submission.